All right, scatterplots and relationships. A scatterplot investigates the relationship. I don't like that color. It investigates the relationship between the number two, variables. The relationship between two variables. So, yes, one might be independent, one might be dependent, or they could really just be independent of each other, which is why we're going to use a scatter plot instead of a line plot. So, a line graph, a bar graph, a histogram, those are going to be when you have two things, an independent and dependent variable. When we have two independent variables like number of pets and shoe size, if you have 3 pets, it's not going to necessarily mean you have bigger shoes. Or if you have bigger shoes, it's not going to mean you have more pets, right? These aren't really related to each other, but we can still plot them and see if there is a relationship between them. So let's get some numbers here. I'll write them down up here so you don't have to write them on your page, and we'll just draw the graph on your page. So take a minute, and if you don't know your shoe size, figure it out a second. Go. Okay, let's just go around. We'll start up here with Luke. We'll go shoe size first, Luke. Shoe size. 5. 7. 8. 9.5. Yeah. 6.5. 10. 7. You don't have to write these, Ethan.
Oh.
What's your shoe size?
Oh, 11 and a half.
I'm going to run out of space.
7 and a half. I didn't know I didn't have to write them. I was writing 9. 7 and a half.
Okay, because we're trying to investigate a relationship between pets versus shoe size, we're going to have to go in the exact same order now for pets, so that I put the numbers right underneath the other ones. So here we go with pets.
3.
Okay, I'll come back to you.
2. 3. 2. 1.
Who was first? You each have 1? Did you figure it out, Alex?
Yes,
7.
You should hear Mrs. Van Dyke's list. She's a zoo at her house. 13.
All right. So when we make graphs, we used to figure out which one was the independent and dependent, and those would go on either the X or the Y axis. In this case, because we don't have an independent or dependent, hey John, Owen, pay attention up here. Number of pets versus shoe size, I would usually put the first one on the x-axis, because typically 99.99% of the time in math, they're going to put the first values on the x-axis and the second values on the y-axis. So for ours, if you would, now this is where you get to draw on yours, okay, on your page. So you're going to need to draw your little graph. And number of pets is going to go on our x-axis. What's our largest number of pets? I think that was you, Alex. 7. With 7. So that's going to have to be my biggest number here. Okay. And then you're going to make equal intervals there up to 7. And that wasn't perfect for me, so I'm going to actually erase that a little bit. And no, you don't have to label every single one of these. Okay. And nobody had negative number of pets, so we wouldn't have to do negative numbers either, which is kind of nice. What's our biggest shoe size we have? Biggest shoe size? I got an 11 and a half. So what should we go to, I think, on our line? We should go up to 12. You guys have learned something this year. 12, and if I cut that into thirds, I get 4 and 8. Okay, so then you would plot these different things. So, number of pets, if they have, in this case, 5, it's like ordered pairs. You remember that from last year with a coordinate grid?
Yeah.
So, for us, we did number of pets was our x-axis. So your first coordinate would be 3, 5. So we would go over 3 up to 5 for our first dot. That takes care of these guys.
Wait. Say that again.
So I went 3, 5, number of pets, shoe size, 1, 2, 3 over, 1, 2, 3, 4, 5. I'm a little high there with mine, but we're making our own grid. Yeah, I've got some grid paper if you guys want some. So then what would my next point be?
7.
0, 7. So you don't go over, and then you go up to 7. And then here comes Alex with his 7 pets, shoe size 8.5. So we did this one, and we did this one. And we're not going to do every single one of these, but are you getting the feel for how these go on the grid?
Yeah.
Okay. So scatter plot. Okay, that's making a scatter plot. Now let's think about this one. Average test percent versus homework done. So I will make some numbers up here. So let's do our grid here. And this is percent on the test. And this is percent homework. And let's say, so 100%, right, would be at the top of each of those. Halfway would be 50. Okay. And we're not going to put a lot of data on this one. What would you think? If you did more homework, do you feel like you'd have a better test score?
Yeah.
So probably like way over here, if you did all your homework, most of your homework, you'd do pretty well on your test. Could somebody do worse on the test though?
Yeah.
If they did the same amount of homework?
Yeah.
So somebody could be the same amount of homework, right? So they're at this level with homework, but worse on the test. They could be down here on the test. So that's why we do it on a scatter plot, because they go, so in this case, maybe they did, 90% of their homework and got like a 60%. Like a 60%.
Huh? Yeah, but the nurse is going down.
I'm very touched. So I'm confused. So this means very much confused.
The red cup.
Right?
Yeah.
I don't know why that one erased. All right. Okay. So, Owen, if you do 90% of your homework, and John does 90% of your homework, do you think every time you'll get the exact same score on your test?
No.
Right? You might always do better on your test than John if you do 90% of your homework. So in this case, you do 90% of your homework. Here would be Owen's scores, and here would be John's test scores. Right?
What? But they're in the same place.
They're in because they did the same amount of homework. They did the same amount of homework, but they got different test scores.
Oh, that makes sense.
Okay? So now, Ethan, you could get, let's say you only do, let's put Ethan on here, we'll make him purple. Let's say Ethan does 50% of his homework. But he gets 100% on his test. Could that happen? It could, right? Is it probably going to happen? No, he's probably going to be down lower with that.
That makes sense.
Okay? So scatter plots can have multiple things of the same, but also different locations where for the other axis. So what do you think? In general, it's probably going to be something like that, right? Typically, the lower homework you do, the lower test you get. The more homework you do, the better test grades you get. Would you think that, generally?
Yeah.
Okay. All right, let's do this next one here.
Wait, do we have to do 2 dots for a person?
No, you don't. No, this would be different people.
Oh.
Each dot is a different person.
Okay.
Okay?
Yep.
Let's do this one. Number of times falling asleep in class versus average hours of sleep. So let's draw our grid again.
We want to make it realistic.
And this time I'm going to put the hours of sleep on the x-axis because hours of sleep represents time. And generally time is going to go on your x-axis. So let's say in a night, some people get, I don't know, how much sleep do you get at night? Typically. Like what time do you normally go to bed?
8:30.
What time do you normally get up?
6 o'clock.
6 o'clock, so that's like 11 and a half hours.
I would
Okay.
rather not.
What about you? What time do you go to bed?
Like 9:30.
9:30. What time do you get up?
Like 6:30.
So that's like 8 hours roughly. Is that right? Is that right? 9 hours. 9 hours.
11 through 1.
Okay, what time, okay, let's say 11. What time do you normally get up?
7:45.
7. So you're getting 8 hours,
No, 7:45.
7:45, 8 hours and 45 minutes of sleep if you go to bed at 11. Right?
Not as bad as I thought.
So our biggest number, you were how many hours again? 11. Anybody get more than 11 hours of sleep? So this is sleep here. And let's say we get 11 hours of sleep there. Somebody could get 0 hours of sleep, right? And what would be a top number you think for average hour or average times falling asleep in class? 4 times?
0.
Okay. 4 times. You could have 0 as well, right? Now, in the book, they're going to give you data for all these. We're just kind of making it up as we go right now. So a scatter plot of this data, and each dot represents a different person. So Emery gets 11 hours of sleep, and she falls asleep like no times in class ever. Okay. Emily gets a little less than 11 hours, and she falls asleep every once in a while. Molly, she is somewhere way less sleep and falls asleep in class a lot. Right, so we can just put dots in here, and you were somewhere down there, I don't know where, you're one of those dots.
Ooh,
Okay, so scatter plot. Okay, so we want to make sure everything's labeled. Sorry, I'm right in your way, aren't I? Times falling asleep. Okay. In my examples, I just totally randomly put the dots on there. On your homework, you are going to take a little more time.